Okay, in this video we're going to take a look at finding exact values of the trig ratios of special angles in the coordinate plane. In particular, we're going to focus on the 45, 45, 90 triangles in the coordinate plane. So if we put a 45, 45, 90 triangle in the second quadrant, as we see in the picture, it's going to resemble the following. So if we have it in standard position and then we flip it over the y-axis, we'll have a 45-degree angle between the negative x-axis and our hypotenuse here. And that means if it ends up in the second quadrant, if we put this 45-degree angle in the second quadrant, that means our radius, our hypotenuse, would have rotated 135 degrees to get there. And we can get that by finding half of a full rotation of 180 degrees and then backtracking or subtracting 45 from that. So it's going 180 degrees, but then we're going back 45 degrees, and 180 minus 45 is 135 degrees. So again, 135 degree angle in standard position, positive x-axis for the initial side, terminal side makes a 135 degree angle. That means that the 45 degrees left over to get to the x-axis. This 45 degrees is called a reference angle for 135 degrees. It's essentially an acute angle that our triangle makes with the x-axis, whether it be the positive side or the negative side. So in the second quadrant, your x-coordinates are negative and your y-coordinates are positive. And keep in mind that r, or the hypotenuse, is always going to be positive. So our 45, 45, 90 triangle had a hypotenuse with a length of the square root of 2. And then opposite each of the 45-degree angles was 1. But in the second quadrant, this 1, since it's on the negative x-axis, this 1 in the second quadrant becomes negative 1. And in the second quadrant, our y-coordinates, our y values are positive. So this height of the triangle in the second quadrant, since y's are positive in the second quadrant, our value here is going to remain a positive 1. So by placing these 45, 45, 90 triangles and 30, 60, 90 triangles in the coordinate planes, we get positive and negative values of x and y. So our sine of 135 degrees is going to be the same as the sine of 45 degrees. So looking back at our angle here, the sine of 135 degrees is going to be the sine of this angle here in standard position. And using the 45, 45, 90 triangle in the second quadrant, it's going to be y over r, which is 1 over the square root of 2. And back when we looked at right triangle trigonometry, we simplified that 1 over the square root of 2. We rationalized it as square root of 2 over 2. Cosine of 135 degrees is going to be x over r, and our x coordinate is negative 1. Our value of r is square root of 2. So cosine of 135 degrees is going to be the same as the cosine of this 45 degree angle in the second quadrant, where our x is negative 1 and our r is square root of 2. Negative 1 over the square root of 2, it rationalizes to negative square root of 2 over 2. Tangent of 135 degrees, y over x. The y value is 1, the x value is negative 1, and 1 divided by negative 1 is negative 1. And for the reciprocals, we can more or less do the same thing with reciprocals as we have in the past. So here's our triangle again for 135 degrees. We found the sine, cosine, and tangent already. Cosecant is going to be r over y, or the reciprocal of the sine of 135 degrees. So r square root of 2 over y is 1. We get cosecant of 135 degrees is square root of 2 over 1, or square root of 2. The secant of 135 degrees, r over x, square root of 2 over negative 1, is negative square root of 2. And cotangent of 135 degrees is x over y, which is negative 1 over 1, or negative 1. And again, negative 1 is the reciprocal of negative 1. Part B, 225 degrees. So 225 degrees is going to end up in the third quadrant, which means if we think of how many degrees that the hypotenuse here, or the value of r, makes with the negative x-axis, that's this angle right here, that's going to be a 45 degree angle. And in the third quadrant, our values of x are negative and our values of y are also negative. So this point on the end of the circle here, the rotating circle, this point has a negative x coordinate and a negative y coordinate. But remember, r is always positive. So we have a -1 for x, a -1 for y, and a square root of 2 if we were to just remove this triangle from the coordinate plane. So our sine of 225 degrees is going to be y over r, -1 over the square root of 2, rationalizes as negative square root of 2 over 2. Our cosine of 225 degrees, x over r, -1 over square root of 2, is negative square root of 2 over 2. And our tangent of 225 degrees, y over x, -1 over -1, is 1. Now for the reciprocals, the cosecant r over y, square root of 2 over -1. Next up is secant r over x, square root of 2 over -1. And finally, cotangent x over y, -1 over -1, is just 1, or the reciprocal of tangent. All right, part C, we have 315 degrees. So here, 315 degrees, we end up in the fourth quadrant. And in order to find out the value of this angle, this reference angle here, we would go 360 degrees minus the 315 degrees that we rotated. That means this angle here is 45 degrees again. So in the fourth quadrant, your x coordinates are positive, your y coordinates are negative. So if we look at this point in the fourth quadrant, it's going to have a positive x coordinate and a negative y coordinate. And with the 45, 45, 90, it's going to be a positive 1 for x and a negative 1 for y. So positive 1 for x, negative 1 for y. Truth be told, even if this was a value, if we went out 10 and -10, then the hypotenuse, the value of r, would be 10 times the square root of 2. So just like we talked about before, it really is independent of the values here and here. Your x's and y's are going to be the same, might be positive or negative. Your hypotenuse, or r, is going to be the length times square root of 2. So our sine of 315 degrees, y over r, -1 over the square root of 2, is negative square root of 2 over 2. Cosine of 315 degrees, x over r, 1 over the square root of 2, is square root of 2 over 2. Again, rationalizing the denominator. Tangent of 315 degrees, y over x, -1 over 1, is -1. And for the reciprocals, cosecant r over y, square root of 2 divided by -1, is negative square root of 2. For secant r over x, square root of 2 divided by 1 is square root of 2. And for cotangent, x over y, 1 divided by -1 is -1, or it's, again, the reciprocal of the tangent of 315 degrees. All right, so that about does it for this video. In the next one, we're going to take a look at some 30, 60, 90 triangles in the coordinate plane. So I will see